UL 498, the standard for safety for attachment plugs and receptacles, specifically addresses the use of stranded conductors and wire wrap connections. Section 5.13.4 of UL 498 states that stranded conductors shall not be used for wire wrap connections. This means that when you are using a wire wrap connection, such as those found on many receptacles and switches, you must use solid conductor wire. The reason for this restriction is due to the nature of stranded wire and the design of wire wrap terminals. Stranded wire is composed of multiple strands of metal twisted together, which gives it flexibility. However, this flexibility also makes it more susceptible to deformation under pressure. When a stranded wire is wrapped around a screw terminal and tightened, the individual strands can split out or become compressed unevenly. This can lead to a poor connection, increased resistance, and potentially overheating or even fire. Solid wire, on the other hand, is a single, solid piece of metal. It maintains its shape better under pressure and provides a more consistent and reliable connection when used with wire wrap terminals. Now let's consider the National Electrical Code, or NEC. NEC Section 110.14c references UL 498 for the use of stranded conductors in wire wrap connections. This means that the NEC adopts the UL 498 standard regarding this issue. By referencing UL 498, the NEC reinforces the prohibition of using stranded conductors in wire wrap connections for receptacles and switches. It is important to note that this restriction applies specifically to wire wrap connections. Other types of connections, such as those that use pressure connectors or terminals specifically designed for stranded wire, may be acceptable for use with stranded conductors. However, for wire wrap connections, such as the screw terminals found on many common receptacles and switches, solid wire is required. Understanding this requirement is crucial for ensuring safe and reliable electrical installations. Using the correct type of wire for the type of connection is a fundamental principle of electrical work. By adhering to the UL 498 standard and the NEC guidelines, you can help prevent potential hazards associated with improper wiring practices. In summary, when working with wire wrap connections on devices like receptacles and switches, always use solid conductor wire. Refer to UL 498 Section 5.13.4 for the specific prohibition of stranded conductors in these applications. Also, be aware that NEC Section 110.14c references UL 498, making this requirement part of the National Electrical Code. Let's delve deeper into the specifics of UL 498 and NEC 110.14c to fully understand the implications of these standards on electrical installations. UL 498, as the standard for safety for attachment plugs and receptacles, sets the bar for the safety and performance of these devices. Section 5.13.4, which explicitly prohibits the use of stranded conductors in wire wrap connections, is just one piece of a larger framework designed to minimize electrical hazards. The prohibition exists because stranded conductors, when subjected to the pressure of a wire wrap screw, can behave unpredictably. Unlike solid conductors, which maintain their form under compression, stranded conductors can deform, splay, and even break individual strands. This deformation compromises the contact area between the conductor and the terminal, leading to increased resistance. Increased resistance, in turn, generates heat, which can degrade the insulation of the wire, damage the receptacle or switch, and ultimately create a fire hazard. Furthermore, the uneven pressure distribution on the individual strands of a stranded conductor can lead to a loose connection over time. Vibrations, thermal expansion and contraction, and other environmental factors can exacerbate this loosening, further increasing the risk of a faulty connection. Solid conductors, due to their inherent rigidity and uniform cross-section, provide a more stable and reliable connection in wire wrap applications. They maintain consistent contact pressure and are less susceptible to deformation and loosening. Now let's turn our attention to NEC 110.14c, which addresses the connection of conductors to terminal parts. This section of the NEC is crucial because it acknowledges the importance of proper termination techniques for ensuring safe and reliable electrical systems. By referencing UL 498, NEC 110.14c essentially incorporates the UL standards prohibition of stranded conductors and wire wrap connections into the National Electrical Code. This means that compliance with UL 498 is not just a recommendation, it's a requirement under the NEC. The NEC reference to UL 498 underscores the significance of using only approved and listed equipment in accordance with the manufacturer's instructions. This is a fundamental principle of electrical safety, as it ensures that the equipment has been tested and evaluated to meet specific safety standards. When installing receptacles and switches, electricians must be aware of the UL 498 restriction and the NEC 110.14c reference. This awareness ensures that they select the appropriate type of conductor for the wire wrap connections and avoid using stranded conductors in these applications. Using the correct type of conductor for the connection type is not merely a matter of code compliance, it is a critical safety measure. It prevents potential hazards such as overheating, arcing, and electrical fires, protecting both property and lives. In addition to understanding the UL 498 and NEC 110.14c requirements, electricians should also be familiar with other relevant sections of the NEC that pertain to conductor terminations. These sections provide guidance on proper torquing of terminal screws, the use of antioxidant compounds, and other best practices for ensuring reliable and safe electrical connections. It's also important to note that while UL 498 prohibits stranded conductors and wire wrap connections, it does not prohibit the use of stranded conductors altogether. Stranded conductors are commonly used in many other electrical applications, such as branch circuits and feeders, where their flexibility is advantageous. However, when it comes to wire wrap connections on receptacles and switches, solid conductors are the only acceptable choice. To further clarify the application of these standards, let's consider a few practical examples. Imagine an electrician is installing a new receptacle in a residential dwelling. The electrician has a spool of 12 American wire gauge solid copper wire and a spool of 12 American wire gauge stranded copper wire. According to UL 498 and NEC 110.14c, the electrician must use the solid copper wire for the wire wrap connections on the receptacle. Using the stranded copper wire would violate both the UL standard and the NEC requirement. Now imagine a different scenario. An electrician is installing a lighting fixture that requires connecting several conductors together. The electrician decides to use wire nuts to make these connections. In this case, the electrician may use either solid or stranded conductors, as wire nuts are designed to accommodate both types of wire. However, the electrician must ensure that the wire nuts are properly sized for the number and gauge of conductors being connected and that the connections are made according to the manufacturer's instructions. These examples illustrate the importance of understanding the specific requirements for each type of electrical connection. Not all connections are created equal, and each type of connection has its own set of best practices and code requirements. By following these guidelines, electricians can ensure that their electrical installations are safe, reliable, and compliant with all applicable standards. In conclusion, the prohibition of stranded conductors and wire wrap connections on receptacles and switches is a crucial safety measure that is enforced by both UL 498 and NEC 110.14c. By understanding these standards and adhering to them, electricians can prevent potential hazards and ensure the safety of electrical systems. Remember to always use solid conductors for wire wrap connections and to consult the NEC and other relevant standards for guidance on proper wiring practices. Let's expand on the reasons why solid conductors are preferred over stranded conductors and wire wrap connections, focusing on the long-term reliability and safety aspects. Firstly, the contact area between the conductor and the terminal screw is more consistent and stable with solid conductors. Because solid wire maintains its shape under pressure, the contact area remains relatively constant over time. This consistent contact area ensures a low resistance connection, which minimizes heat generation and reduces the risk of arcing. Secondly, solid conductors are less prone to corrosion than stranded conductors and wire wrap connections. The individual strands of a stranded conductor can create small air gaps where moisture and contaminants can accumulate, leading to corrosion. This corrosion can increase resistance and weaken the connection over time. Solid conductors, with their smooth, uniform surface, are less susceptible to this type of corrosion. Thirdly, solid conductors are easier to install and maintain in wire wrap connections. The rigidity of solid wire makes it easier to wrap around the terminal screw and tighten securely. Stranded wire, on the other hand, can be difficult to manipulate and can sometimes fray or unravel during installation. Fourthly, solid conductors are less likely to loosen over time due to vibration or thermal cycling. The solid core of the wire provides greater resistance to these forces, ensuring a more stable and reliable connection. Stranded conductors, with their multiple strands, are more susceptible to loosening under these conditions. In addition to these factors, it's important to consider the overall system design when selecting conductors for wire wrap connections. The size and type of conductor should be appropriate for the load it will be carrying and the environmental conditions it will be exposed to. Using undersized conductors or conductors that are not rated for the environment can lead to overheating, corrosion, and other problems. Furthermore, the terminal screws themselves should be properly torqued to ensure a secure connection. Over-torquing can damage the screw or the conductor, while under-torquing can result in a loose connection. The manufacturer's instructions should be consulted for the proper torque values. The use of antioxidant compounds can also help to prevent corrosion and improve the reliability of wire wrap connections. These compounds create a protective barrier between the conductor and the terminal, preventing moisture and contaminants from reaching the metal surfaces. They also help to improve the conductivity of the connection by filling in any microscopic gaps between the conductor and the terminal. It is crucial to remember that electrical safety is not just about following the code requirements, it's about understanding the underlying principles and best practices. By taking the time to learn about the reasons behind the rules, electricians can make informed decisions and ensure that their electrical installations are safe, reliable, and compliant with all applicable standards. In conclusion, the prohibition of stranded conductors and wire wrap connections on receptacles and switches is a well-founded safety measure that is supported by both UL 498 and NEC 110.14c. Solid conductors provide a more consistent, stable, and reliable connection in these applications, reducing the risk of overheating, arcing, and electrical fires. By understanding these standards and adhering to them, electricians can ensure the safety of electrical systems and protect both property and lives. Let's explore some of the exceptions and nuances related to the use of stranded wire in electrical systems, and how they relate to the specific prohibition in wire wrap connections. Firstly, while UL 498 and NEC 110.14c prohibit stranded wire in wire wrap connections on receptacles and switches, they do not prohibit the use of stranded wire in other types of electrical connections. Stranded wire is commonly used in many other applications, such as branch circuits, feeders, and equipment wiring, where its flexibility is advantageous. In these applications, stranded wire is typically connected using crimp connectors, pressure connectors, or other types of terminals that are specifically designed for use with stranded conductors. Secondly, some receptacles and switches are designed with terminals that are specifically approved for use with stranded wire. These terminals typically have a clamping mechanism that securely grips the individual strands of the wire, providing a reliable connection. However, it is important to note that these types of receptacles and switches are less common than those with traditional wire wrap terminals. When using receptacles and switches with terminals approved for stranded wire, it is essential to follow the manufacturer's instructions carefully to ensure a proper and safe connection. Thirdly, in some cases, stranded wire may be permitted in wire wrap connections if it is properly prepared and terminated. This typically involves using a crimp-on ferrule to consolidate the strands of the wire and provide a solid contact surface for the terminal screw. However, this practice is generally discouraged, as it can be difficult to ensure a consistent and reliable connection. It is always best to use solid wire in wire wrap connections whenever possible. Fourthly, it is important to distinguish between different types of stranded wire. Some stranded wire is designed for general-purpose wiring, while other types are designed for specific applications such as flexible cores or high-temperature wiring. The type of stranded wire used should be appropriate for the application and should be selected in accordance with the NEC and other applicable standards. Fifthly, it is important to consider the environmental conditions when selecting conductors for electrical installations. In corrosive environments, it may be necessary to use conductors with special coatings or insulation to prevent corrosion. In high-temperature environments, it may be necessary to use conductors with high-temperature insulation. Sixthly, it is essential to follow the manufacturer's instructions when installing electrical equipment. The manufacturer's instructions will provide guidance on the proper type of wire to use, the proper torque values for terminal screws, and other important installation details. Failure to follow the manufacturer's instructions can void the warranty and can create a safety hazard. Seventhly, it is important to remember that the NEC is a minimum standard. In some cases, it may be necessary to exceed the NEC requirements to ensure a safe and reliable electrical installation. For example, in critical applications, it may be prudent to use larger conductors or more robust terminals than what is required by the NEC. Eighthly, it is crucial to stay up to date on the latest changes to the NEC and other applicable standards. The electrical industry is constantly evolving and new technologies and best practices are emerging all the time. By staying informed, electricians can ensure that their electrical installations are safe, reliable, and compliant with all applicable standards. Ninthly, it is important to seek professional guidance when needed. Electrical work can be complex and dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. A qualified electrician can assess the situation, provide expert advice, and ensure that the electrical installation is done safely and correctly. Tenthly, it is crucial to prioritize safety above all else. Electrical safety should be the top priority in every electrical installation. By following the code requirements, using proper techniques, and seeking professional guidance when needed, electricians can help to prevent electrical accidents and protect both property and lives. In summary, while UL 498 and NEC 110.14z prohibit stranded wire and wire wrap connections on receptacles and switches, there are some exceptions and nuances to consider. Stranded wire is commonly used in other types of electrical connections, and some receptacles and switches are designed with terminals specifically approved for use with stranded wire. However, it is always best to use solid wire and wire wrap connections whenever possible, and to follow the manufacturer's instructions carefully to ensure proper and safe connection. Always prioritize safety and seek professional guidance when needed.